We're entering the final stretch with our fourth and last topic, consolidation on Exadata. There are many advantages to consolidating Oracle on Exadata, and several things that you should keep in mind when doing so. For this session, Shankar is joined by Jim Olson, who is based in Atlanta.
So when we talk about consolidation, with today's database and Exadata engineered systems, we see a lot of customers doing more and more database consolidation and maximizing their resource utilization while pushing their cost way down. We see many different reasons that this is an effective way to consolidate. First of all, simplicity is really a big piece of what we're seeing. The engineered system is delivered, configured, and ready to go for both OLTP, mixed workloads, and all sorts of combined workloads. On top of that, quite frankly, Exadata is the best environment to deploy your database. It's not a do-it-yourself configuration. Exadata provides the best performance to run your Oracle database, hands down. In addition, Exadata with the Oracle database provides the most highly available environment possible. Not only does it provide a highly available environment, it provides environment that has service levels of different availability depending on your database needs. We use our maximum availability architecture to achieve this. And very similar to high availability, we have many security features that will allow us to deploy databases with different security needs based on business or system need of the environment. So how do we get here? Why are we consolidating databases and looking to bring databases into a single environment? Well, we really are trying to eliminate database sprawl. In today's world, we see many different databases. People are running on different servers with different storage vendors. We have all sorts of different operating systems, from Windows to Linux to different proprietary systems like AIX. We see all different types of virtualization, VMware, Microsoft Hyper-V, and even OpenStack type of virtualizations where people are deploying databases. We see all different mixes and matches of operating system and database versions. We see all sorts of different high availability needs. And on top of this, all these different combinations lead to very, very hard to secure environments that with thousands of different security attack points. So you have mission critical databases, departmental databases, test and development databases, all in the same mix of hardware within our environments. And it just leads to a lot of wasted resource and a cost that is driven way up by the need to purchase new systems and add new hardware just to add different new implementations of databases or to handle growth of databases. So what we really want to talk about is a little bit more detail is how we can deploy a consolidation approach with Exadata in an Oracle environment. We can do it in a very simple manner, a very performant manner. We can provide the highest availability possible and tiers of availability and security that is unmatched within the industry. So let's first dive into simplicity and why Exadata and Oracle database consolidation in an engineered system like Exadata makes a simple approach. So if you look at how we really have deployed first in how we've been deploying databases for a long time, at the very top of our chart here, we have databases on dedicated servers. So we have a database that's running on a server. As we size that server, we have to size that server for the highest processing needs that we might have, the peak processing needs. So during peak processing, we have the ability to handle the capacity that we need. However, we're not always processing at peak performance. A lot of times we're processing well under peak performance. So if we size an environment for peak performance, we can oftentimes waste a ton of resource within that single machine. So what people have done as we move down this chart is they've been implementing virtual machines within a single physical machine. What this allows us to do is spin up operating systems and then build a database in each one of those individual operating systems. This is a great way to start taking more advantage of available resource and utilizing our environment to take advantage of all the resource. But unfortunately, this is adding complexity. As we need a new database, we spin up a new VM. We need another new database, we spin up a VM, and soon we have hundreds and hundreds of VMs all running individual databases. The problem with this is it leads to a more complex environment. We are taking more advantage of available resource, but we're introducing hundreds of VMs which have hundreds of attack points and hundreds of VMs that need to be upgraded when we have a new release of software. Not all the VMs are up and running all the time, so we may have to introduce bringing VMs up in a whole different complicated plan for an upgrade decision and upgrade processing. So although this can use more resource, it makes things much more complicated and less efficient in the long run. The other way we can take advantage of that single server, rather than building multiple VMs in that server, is to create multiple databases in that server. Now, this is great because we have one operating system, so we don't have to worry about all the different patching and that kind of thing. And we have multiple databases in that machine, so we can bring multiple environments of multiple applications into that single server, and we can take advantage of the entire server. So this is a great way to start thinking about consolidation in a different way than using virtual machines. And then finally, the best way that we see to consolidate is to start looking at a multi-tenant approach. So in this approach, we take one container database, and instead of bringing up many databases, we're bringing in pluggable databases into a picture so that we take advantage of our shared resources through the container, the master database, if you will, and we plug individual databases into that master, that container database, and that container database is really allocating the resources, and the pluggable databases are sharing certain resources. They have unique access to other resources. So it's the best way to take advantage of your CPU and memory resources within a single server. So if we look at this from top down, we see different layers of consolidation options. And what we see at the end of the day is that the best approach is to have a small number of virtual machines with container databases and Oracle databases deployed within a small number of virtual machines, and using virtual machines for isolating where we need to have isolation for departmental needs or processing needs. This is a picture of exactly what I'm saying. We need to look at virtualization as a means of isolating environments within an environment. We're not using virtualization as a service type of mechanism to spin up a new database. We're not going to spin up a new VM every time we need a new database. We're going to use virtualization as a means to isolate environments. In this case, we're isolating production and non-prod, data warehousing and OLTP into their own virtual machines. In this case, we're looking at 6 virtualized machines within the Exa environment, and we're doing this to isolate based on business requirements. Prod and test dev, data warehousing, and OLTP. We're isolating those environments and being able to control those environments independently rather than spinning up databases within virtual machines for every single environment we need.
So Jim, real quickly, this is Shankar. On the consolidation, the methods of consolidation, one of the options that we have seen with customers is they would actually create virtual machines for every line of business. So that way they have all the line of the business databases consolidated in a single cluster, in a single VM, but then they're also reducing the database sprawl that you talked about.
Yep. That makes sense. And I think that's exactly what we're talking about, right, Shankar, is that We're not trying to add VMs just to simply add another environment where an individual needs a database. And if we have 100 developers, we're not going to spin up 100 VMs and give each developer a VM.
Right.
We're trying to limit that, just like you said. So thanks
Yep.
for that. That's
Yeah.
a good point. So if we think about the simplification within an Oracle consolidated environment, in an Oracle virtualized environment, as opposed to a do-it-yourself type of environment where we're piecing together equipment and software to provide database and access to our databases, I'd like to compare the do-it-yourself to the Oracle approach and what we're talking about. So in the left side here, you see we're trying to bring up 8 different Oracle environments for 8 applications. We're using different servers. We're using a hypervisor, so a virtualization layer with virtual machines. Each one of those virtual machines has an operating system running on that virtual machine, and then we load an Oracle database into that virtual machine. If you look at the do-it-yourself version, we have 28 configuration items. In other words, 28 individual points that we're maintaining, that we're having to worry about patching and security and all of the different pieces that come along with that. If you take the same approach within the Oracle environment, in other words, you're trying to bring up 8 different applications using 8 different Oracle databases, and you implement that with a multi-tenant environment in an Oracle virtualized environment, here what we've done is we have 2 master domains, we have 4 virtual machines, we have 4 container databases, and 8 pluggable databases, and we've reduced our configuration items to 18. So almost half of the configuration items as opposed to the do-it-yourself environment. This helps keep your utilization up and your processing overhead way down. It's much simpler. It minimizes the patching and attack points that you have because you have less configuration items. So it becomes much more easy to manage and a much more simple approach overall than the do-it-yourself version. And it's a single vendor, right? We're using a single vendor to implement this. So much more efficient. We're talking 8 databases. What if we were talking 80 databases or 800 databases? And think about the simplicity savings there. We're going from 20 to 18 in this case. We could be going from 100 to 50 configuration items as we grow this. So very key point, and when we talk simplicity, is the fact that we're reducing the number of points that we have to maintain and manage within this type of consolidated environment. So multi-tenancy, I brought it up. This is an option with the Oracle database, and if you are consolidating, you do not have to use multi-tenancy. You can bring up multiple databases in your virtualized environment or in your bare metal environment and achieve an effective consolidation approach that way. A more effective way is, and as we go forward with 19C and 20C in the future, will be to use a multi-tenant architecture. This allows you to take that container database and plug databases in here. It allows for you running many different types of application within a single container environment. It allows for rapid provisioning. It allows for great portability between environments. It just helps you maximize your hardware expense, you maximize your hardware resources and minimize the hardware expense, minimize your operational expenses as we don't have as much people power and operational cost with this type of model, and it just becomes much simpler to maintain, to clone, to replicate, to implement high availability strategies when you look at a multi-tenant approach with the Oracle database. Another key piece of consolidation would be looking at leveraging Exadata snapshots. Now, this is a technology that's available in Exadata, and it allows us to take our production database, make a copy of that database with something like DataGuard or our man clone database, and we can take that full copy of the database, make it read-only, and then make snapshots of that read-only database, which are read-writable. So many different use cases for snapshot databases. We can look at those for test development, giving our developers all their individual copy of production data, so to speak, so they can all have a look at production data and develop with production data. We can look at taking a 12C database, that's our test master, that master read-only copy, and then upgrading within our snapshot to 19C, so we can then run our application against the snapshot and see how that reacts with the upgrade. Is it going to perform this, have the same type of explain plans and performance type of direction that we would see with a production copy of the database? The nice thing about snapshots is, first, they're very quick to provision. In other words, we can make a copy of our database, which is a production view, a full view of our production data, in just minutes. Okay, we don't have to take hours to copy that 40 terabyte data and physically copy 40 terabytes of data to have a development database. And if we have 10 developers, we don't have to copy 40 terabytes 10 times to create 10 databases. We can copy those very quickly as a thin provision database that points back to the master copy. The snapshot is a database which is an allocate on first write technology, which means we allocate blocks when we write to those blocks, and the rest of the database, the rest of the data file, is a pointer back to the master copy. So we don't have the duplicate type of data. We don't realize all of the data in our copy. It's basically a zero-size data file with just change blocks written to the sparse area when we create that snapshot database. So very space efficient, very time effective when we're creating the snapshots, and it's a key piece to having a development environment that's effective within an Exadata environment, and using Exadata for consolidation for a test dev and a QA type of approach. The last thing I'll bring up when we talk about consolidation and the simplicity to our consolidation approach is that we have a very specific approach to consolidating databases in Exadata, a step-by-step approach that allows us to start by inventorying databases and end up deploying in an Exadata environment. It's a prescribed type of approach to consolidate in Exadata, and there's tools that we have for these different steps within Enterprise Manager and the Exadata environment to help you along the way as you're doing this. So a very straightforward mechanism to look at categorizing and providing your self-service levels and how we actually implement that in Exadata, so you don't have to go through a bunch of different steps. So it makes it much simpler.
So one of the other things, Jim, related to consolidation is there are customers that have a whole bunch of databases that are eligible for consolidation, but they may phase out like a phase 1, phase 2, etc. They may phase out the more important, more critical databases in the phase 1, and they can grow beyond. After 6 months or so, they can add additional databases, and tools, OEM tool like Capacity Planner can help them out to figure out what is the relevant capacity in terms of CPU, memory, storage, and IO that is required for getting all these additional databases on Exadata. So there is that functionality available as well.
That's an excellent point, Shankar. And really what we're talking about is a couple of things there. Number one is nobody is going to go out and take 100 databases and consolidate those all in one day and turn the switch on, right? We can have a phased approach, and that's what you were talking about exactly, is that you can start out with a key set of databases or a certain service level of databases. Start with those and grow out your consolidation and add to your environment as you have new databases within a different service level or different service category, and grow it that way. And the database gives you a great way to do that with multi-tenant or just the normal Oracle database, as well as the Exadata hardware, right? We can start out capacity on demand, which we'll talk about in a minute, with a small number of cores, and grow to a more full utilized system in a number of cores, and then even add database nodes into the system or add storage cells if we need more storage capacity. So we'll talk about that more too. That's an excellent point. Thanks, Shankar, for that comment. You're exactly right. We talked about simplicity of consolidation with the Exadata engineered system and the Oracle database. The next thing I'd like to do is talk about performance. And over the history of Exadata, which is really about 12 years old at this point, we've seen that we've always had Oracle database innovations that have come along, from Oracle version 10 to 11 to 12 to 19C where we are. We've always had the ability to depend on new database features or improved database features like multi-tenant, in-memory, partitioning, compression, all sorts of features that make Oracle database the best database to consolidate on. When you start looking at how the database works in an Exadata database machine, we now have all sorts of components that enhance the database that are only available in the Exadata database machine, that make this database machine the best platform to locate your consolidation efforts for the Oracle database. So the Oracle database itself, fantastic platform to consolidate with. When you add this into the Exadata machine, you really have an unmatched platform, because we have smart caching, we have columnar flash, we have resource management, we have hybrid compression, all of these things that have been added on top of the Oracle database to improve the performance and abilities to consolidate. When we start talking about consolidation and bringing many different workloads into an environment, OLTP workloads, data warehousing workloads, test dev workloads that may not need as much I/O as production workloads, we need the ability to manage those different workloads and manage those environments and control the resource within those environments. Exadata and the Oracle database allows us many mechanisms to control the resource, from the CPU to the database resource consumption to the I/O resource consumption. We have a mechanism in place. Database CPU caging allows us to actually assign CPU to a specific database within a database node. So we can say database 1 gets 16 cores, database 2 gets 14 cores, and we can make sure that we don't exceed CPU quota for existing databases in our environment. On top of that, we have the ability to control resource within a database or a pluggable database based on different categories. So we can set up different categories within our database or pluggable database, like ETL processing, ad hoc processing, batch processing, and assign different resource plans to those, different amounts of resource to those different categories, so that we can ensure that ETL gets a certain amount of processing, or ad hoc queries get a certain amount of CPU for processing. And then we can also control processing within that. So if we have runaway queries, we can make sure that nothing's taking more than a certain amount of CPU time or clock time, or does more I/O than we want a process to allow. So a great way to control database resource. That's within the database itself. But we also have the ability to control the I/O subsystem. So we have I/O resource manager in place. We can control I/O at the database level. We can control I/O in categorized database levels. So we can set up database, IO resource plans for a group of databases, or we can even control IO within a database and say, hey, based on those database resource plans we just talked about, those different database resource categories, let's assign an amount of IO. So the bottom line here is that we can control resource and make sure that one database doesn't hog the system, so to speak, and consume more resource than we would like that database to consume. And we can do this at the CPU level, we can do it within the database level, and we can do it in our IO storage subsystem. Very important topic when you start talking about consolidating many databases into an environment is how do we make sure that we have enough resource for our environment and control the resource within the environment effectively.
Quickly, Jim, I wanted to mention that one of the resource management techniques is on flash cache, which provides the ability to control in terms of setting up the threshold as well as limiting the flash allocation to different databases, as well as whatever we do for flash, we can also do for persistent memory.
That's a great point. Maybe we have a production environment with OLTP and we have our data warehousing environments in the same system, and we also have our test dev and we're utilizing those snapshots, so we have many test dev snaps in that environment. Maybe we decide that our test dev databases don't need to use any of the PMEM. Why waste our PMEM with test dev environments? Let's say turn it off for the test dev environments so that the test dev environments don't go in that P memory and waste PMEM and take that away from our production databases. So that's a great point, is that we can manage that down to that kind of level within the environment if we need to look at that. So that's an excellent point. I think another piece of the performance issue topic, if you will, is the fact that when we're consolidating, and we mentioned it earlier, you may not start off by consolidating everything at once. You may not have a need for an entire database platform all at once from your amount of cores. Now, in a database node today with X8M, there's 48 cores and 98 threads. So there's a lot of processing power within a single database node. In a quarter rack is 2 database nodes and 3 storage cells. So a lot of processing capability there. We have the ability to start off small with capacity on demand and limit the number of cores and the number of licenses that you need within your Exadata environment. And then as you grow, as you're adding to the environment, you can enable more cores and you can add more database storage, more database nodes, so more database processing power, or more storage servers as you need them. So if you need more storage space, you need more throughput, you need more IOPS, you add storage servers. You need more database power, you need to have more connections to your databases, more sessions, you can add more database nodes. And once again, you can start out with a fraction of a database node with our capacity on demand and only license as little as 14 cores on a database node. So the ability to start off small and grow as you grow and you start consolidating more and more and more into your Exadata environment. So talked about simplicity, talked about performance. The next thing I'd like to do is talk about availability. And quite frankly, the Oracle database provides you the most highly available database environment possible in the industry. On top of that, when you go into the Exadata environment, this is no longer do-it-yourself. The Exadata environment has been developed and engineered to be the most highly available, redundant hardware infrastructure possible to run your database on top of. So when you combine these two things, we can provide the most highly available database possible in the industry. Maybe some of your systems that are more departmental have a middle of the road type of availability need. So we have the ability to set up our service levels for availability based on your need, and then move databases between these different tiers as needed. As things become more mission critical, we can move them up the chain to the more critical or more exclusive service levels of availability. We call this our maximum availability architecture. This is something that's been around for years and years. Over 20 years of work and effort have gone into this. It keeps evolving as new capabilities come out with the database, new features come out with our new technologies and replication and high availability. We incorporate this into our maximum availability architecture. So once again, this provides you the ability to have different service levels for different needs of databases, the ability to move databases between service levels as they become either more critical or less critical, and these are proven, tested, prescribed methods. You don't have to come up with the mechanism for a gold service level. We have this prescribed. It's been tested. There's a reference architecture, if you will, for that service level on how you make this happen. So when you need that most critical, no downtime, always available environment, rolling upgrade capable environment with no downtime, you can go to that Platinum and know that you have a prescribed Oracle method to get to that type of service level. So very big piece, especially when you're talking about consolidation and knowing how you want to make your consolidation service levels for your different database fit into your business continuity service levels. So much like high availability, we really have the same story for security. We have all sorts of security options, whether it's a database vault or it's advanced security and data redaction and data masking and subsetting to encryption from the database level or within the database, transparent data encryption from, an entire database, the data file level to encrypting fields within the database or columns within the database. We have different levels of security that can be implemented for your business needs. So once again, if you're consolidating your databases into a single environment, single engineered system, you don't need the same security level for each one of those databases. Your mission critical databases need the top security possible. Your development databases may not need the same type of security, but if you're doing snapshots of production data, you still need to mask certain pieces of data and do some data redaction possibly with certain columns within your database. So Oracle's approach to security is to provide many different security mechanisms and be able to have those service levels, if you will, just like we talked about for high availability, for different types of databases and different needs of your business. And on top of that, with the Exadata environment, we've done a lot with the engineered hardware to provide security as well. So it's not just the database. We have advanced intrusion detection in our hardware, for example, that says, hey, if files are changing, the Exadata box will notify us that files are changing within the system. So from top to bottom, this engineered system has been built to provide you security at the operating system level, all the way through down to the database level. And to just reiterate, if we're minimizing our number of VMs, we have less intrusion attack points, less points to worry about security with our model than a virtualized model as a service model, such as a VMware approach. So I think to summarize what we've talked about very quickly, the main thing is we're really trying to maximize our resource utilization. Let's not waste computer resource. Let's consolidate and take advantage of our computer resource that we have available to us. When we do this, we can maximize our resource and minimize our costs. We can improve our operational expense and capital expenditures, and by improve, I mean reduce those. We have a very simple environment to do this. The Exadata system is engineered for the Oracle database and provides you a very simple environment to deploy consolidation database approach on top of, as well as the database itself has been designed to run and deploy a simple database consolidation approach. The performance is unmatched. It simply is unmatched. You cannot find another database environment that performs the same as Exadata. The availability, once again, is unmatched. We provide you an environment from the hardware and database standpoint that is the most highly available database possible and allows you to set up service levels for different needs of availability. And it's the same for security, whether it's your most secure data down to your development data that may not need as much security. We provide you the top level security and protection within the database environment and the ability to tier your databases as security might need, your security needs might demand. So we summarize what, but really here's why. We want to simplify with Exadata. We don't want you doing it yourself and putting all sorts of different hardware components together and growing by adding a new storage array or a new server and having all these mix of storage and mix of servers. We don't want all sorts of different vendors, from storage vendors software to virtualization software to operating software. We want you to consolidate in a low risk manner. Go to an engineered system that's been built for applications, deploying your applications in the databases in an engineered environment that has been tested. It's been developed to provide you a very simple, performant, secure, highly available environment and eliminate all those risk factors by putting many different pieces together. So that's really the consolidation story. Shankar, would you like to add just your summary of this as well?
Yeah, so there have been analysis done on the latest X8M platform as part of the industry analyst study. For example, Wikibon had done a similar comparison of do-it-yourself systems versus Exadata X8M. One of the things they found out is it costs much more, 48% more, to come up with something like what the Exadata capabilities provide. And number two is, with having spent that amount, you can get only a small fraction of the capabilities that Exadata X8M provides. So overall, from the cost perspective, Exadata consolidation with X8M gives you high productivity, much higher productivity, and is the best place to go.
Thanks for that feedback, Shankar. I'd like to also thank everybody today for joining us on the Consolidation with Exadata virtual Exadata session.